Paper 58. Life Establishment on Urantia. In all Satania, there are only 61 worlds similar to Urantia, life modification planets. The majority of inhabited worlds are peopled in accordance with established techniques. On such spheres, the life carriers are afforded little leeway in their plans for life implantation. But about 1 world in 10 is designated as a decimal planet and assigned to the special registry of the life carriers. And on such planets, we are permitted to undertake certain life experiments in an effort to modify or possibly improve the standard universe types of living beings. 1. Physical life prerequisites. 600 million years ago, the Commission of Life Carriers sent out from Jerusalem arrived on Urantia and began the study of physical conditions preparatory to launching life on world number 606 of the Satania system. This was to be our 606th experience with the initiation of the Nebudan life patterns in Satania, and our 60th opportunity to make changes and institute modifications in the basic and standard life designs of the local universe. It should be made clear that life carriers cannot initiate life until a sphere is ripe for the inauguration of the evolutionary cycle. Neither can we provide for a more rapid life development than can be supported and accommodated by the physical progress of the planet. The Satania life carriers had projected a sodium chloride pattern of life. Therefore, no steps could be taken toward planting it until the ocean waters had become sufficiently briny. The Urantia type of protoplasm can function only in a suitable salt solution. All ancestral life, vegetable and animal, evolved in a salt solution habitat, and even the more highly organized land animals could not continue to live did not this same essential salt solution circulate throughout their bodies in the bloodstream, which freely bathes, literally submerses every tiny living cell in this briny deep. Your primitive ancestors freely circulated about in the salty ocean. Today, this same ocean-like salty solution freely circulates about in your bodies, bathing each individual cell with a chemical liquid in all essentials comparable to the salt water which stimulated the first protoplasmic reactions of the first living cells to function on the planet. But as this era opens, Urantia is in every way evolving toward a state favorable for the support of the initial forms of marine life. Slowly but surely, physical developments on Earth and in adjacent space regions are preparing the stage for the later attempts to establish such life forms as we had decided would be best adapted to the unfolding physical environment, both terrestrial and spatial. Subsequently, the Satania Commission of Life Carriers returned to Jerusalem, preferring to await the further breakup of the continental landmass, which would afford still more inland seas and sheltered bays, before actually beginning life implantation. On a planet where life has a marine origin, the ideal conditions for life implantation are provided by a large number of inland seas, by an extensive shoreline of shallow waters and sheltered bays, and just such a distribution of the Earth's waters was rapidly developing. These ancient inland seas were seldom over 500 or 600 feet deep, and sunlight can penetrate ocean water for more than 600 feet. And it was from such seashores of the mild and equable climes of a later age that primitive plant life found its way onto the land. There, the high degree of carbon in the atmosphere afforded the new land varieties of life opportunity for speedy and luxuriant growth. Though this atmosphere was then ideal for plant growth, it contained such a high degree of carbon dioxide that no animal, much less man, could have lived on the face of the earth. 2. The Urantia atmosphere. The planetary atmosphere filters through to the Earth about 1/2 billionths of the Sun's total light emanation. If the light falling upon North America were paid for at the rate of 2 cents per kilowatt-hour, the annual light bill would be upward of $800 quadrillion. Chicago's bill for sunshine would amount to considerably over $100 million a day. And it should be remembered that you receive from the sun other forms of energy. Light is not the only solar contribution reaching your atmosphere. Vast solar energies pour in upon Urantia, embracing wavelengths ranging both above and below the recognition range of human vision. The Earth's atmosphere is all but opaque to much of the solar radiation at the extreme ultraviolet end of the spectrum. Most of these short wavelengths are absorbed by a layer of ozone which exists throughout a level about 10 miles above the surface of the Earth, and which extends spaceward for another 10 miles. The ozone permeating this region at conditions prevailing on the Earth's surface would make a layer only 1/10 of an inch thick. Nevertheless, this relatively small and apparently insignificant amount of ozone protects Urantia inhabitants from the excess of these dangerous and destructive ultraviolet radiations present in sunlight. But were this ozone layer just a trifle thicker, you would be deprived of the highly important and health-giving ultraviolet rays which now reach the Earth's surface, and which are ancestral to one of the most essential of your vitamins. And yet some of the less imaginative of your mortal mechanists insist on viewing material creation and human evolution as an accident. The Urantia midwayers have assembled over 50,000 facts of physics and chemistry which they deem to be incompatible with the laws of accidental chance, and which they contend unmistakably demonstrate the presence of intelligent purpose in the material creation. And all of this takes no account of their catalogue of more than 100,000 findings outside the domain of physics and chemistry, which they maintain prove the presence of mind in the planning, creation, and maintenance of the material cosmos. Your sun pours forth a veritable flood of death-dealing rays, and your pleasant life on Urantia is due to the fortuitous influence of more than 200 apparently accidental protective operations similar to the action of this unique ozone layer. Were it not for the blanketing effect of the atmosphere at night, heat would be lost by radiation so rapidly that life would be impossible of maintenance except by artificial provision. The lower 5 or 6 miles of the Earth's atmosphere is the troposphere. This is the region of winds and air currents which provide weather phenomena. Above this region is the inner ionosphere, and next above is the stratosphere. Ascending from the surface of the Earth, the temperature steadily falls for 6 or 8 miles, at which height it registers around 70 degrees below 0 Fahrenheit. This temperature range of from 65 to 70 degrees below 0 Fahrenheit is unchanged in the further ascent for 40 miles. This realm of constant temperature is the stratosphere. At a height of 45 or 50 miles, the temperature begins to rise, and this increase continues until, at the level of the auroral displays, a temperature of 1200 degrees Fahrenheit is attained, and it is this intense heat that ionizes the oxygen. But temperature in such a rarefied atmosphere is hardly comparable with heat reckoning at the surface of the Earth. Bear in mind that 1/2 of all your atmosphere is to be found in the first 3 miles. The height of the Earth's atmosphere is indicated by the highest auroral streamers, about 400 miles. Auroral phenomena are directly related to sunspots, those solar cyclones which whirl in opposite directions above and below the solar equator, even as do the terrestrial tropical hurricanes. Such atmospheric disturbances whirl in opposite directions when occurring above or below the equator. The power of sunspots to alter light frequencies shows that these solar storm centers function as enormous magnets. Such magnetic fields are able to hurl charged particles from the sunspot craters out through space to the Earth's outer atmosphere, where their ionizing influence produces such spectacular auroral displays. Therefore do you have the greatest auroral phenomena when sunspots are at their height, or soon thereafter, at which time the spots are more generally equatorially situated. Even the compass needle is responsive to this solar influence, since it turns slightly to the east as the sun rises and slightly to the west as the sun nears setting. This happens every day, but during the height of sunspot cycles, this variation of the compass is twice as great. These diurnal wanderings of the compass are in response to the increased ionization of the upper atmosphere, which is produced by the sunlight. It is the presence of two different levels of electrified conducting regions in the superstratosphere that accounts for the long-distance transmission of your long and shortwave radio broadcasts. Your broadcasting is sometimes disturbed by the terrific storms which occasionally rage in the realms of these outer ionospheres. 3. Spatial environment. During the earlier times of universe materialization, the space regions are interspersed with vast hydrogen clouds, just such astronomic dust clusters as now characterize many regions throughout remote space. Much of the organized matter which the blazing suns break down and disperse as radiant energy was originally built up in these early appearing hydrogen clouds of space. Under certain unusual conditions, atom disruption also occurs at the nucleus of the larger hydrogen masses. And all of these phenomena of atom building and atom dissolution, as in the highly heated nebulae, are attended by the emergence of flood tides of short space rays of radiant energy. Accompanying these diverse radiations is a form of space energy unknown on Urantia. This short-ray energy charge of universe space is 400 times greater than all other forms of radiant energy existing in the organized space domains. The output of short space rays, whether coming from the blazing nebulae, tense electric fields, outer space, or the vast hydrogen dust clouds, is modified qualitatively and quantitatively by fluctuations of and sudden tension changes in temperature, gravity, and electronic pressures. These eventualities in the origin of the space rays are determined by many cosmic occurrences, as well as by the orbits of circulating matter, which vary from modified circles to extreme ellipses. Physical conditions may also be greatly altered because the electron's spin is sometimes in the opposite direction from that of the grosser matter behavior, even in the same physical zone. The vast hydrogen clouds are veritable cosmic chemical laboratories, harboring all phases of evolving energy and metamorphosing matter. Great energy actions also occur in the marginal gases of the great binary stars, which so frequently overlap and hence extensively commingle. But none of these tremendous and far-flung energy activities of space exerts the least influence upon the phenomena of organized life, the germ plasm of living things and beings. These energy conditions of space are germane to the essential environment of life establishment, but they are not effective in the subsequent modification of the inheritance factors of the germ plasm, as are some of the longer rays of radiant energy. The implanted life of the life carriers is fully resistant to all of this amazing flood of the short space rays of universe energy. All of these essential cosmic conditions had to evolve to a favorable status before the life carriers could actually begin the establishment of life on Urantia. 4. The Life Dawn Era. That we are called life carriers should not confuse you. We can and do carry life to the planets, but we brought no life to Urantia. Urantia life is unique, original with the planet. This sphere is a life modification world. All life appearing hereon was formulated by us right here on the planet. And there is no other world in all Satania, even in all Nebadon, that has a life existence just like that of Urantia. 550 million years ago, the life carrier core returned to Urantia. In cooperation with spiritual powers and superphysical forces, we organized and initiated the original life patterns of this world and planted them in the hospitable waters of the realm. All planetary life, aside from extraplanetary personalities, down to the days of Caligastia, the planetary prince, had its origin in our three original, identical, and simultaneous marine life implantations. These three life implantations have been designated as the Central or Eurasian African, the Eastern or Australasian, and the Western, embracing Greenland and the Americas. 500 million years ago, primitive marine vegetable life was well established on Urantia. Greenland and the Arctic landmass, together with North and South America, were beginning their long and slow westward drift. Africa moved slightly south, creating an east and west trough, the Mediterranean basin, between itself and the mother body. Antarctica, Australia, and the land indicated by the islands of the Pacific broke away on the south and east and have drifted far away since that day. We had planted the primitive form of marine life in the sheltered tropic bays of the central seas of the east-west cleavage of the breaking up continental landmass. Our purpose in making three marine life implantations was to ensure that each great landmass would carry this life with it in its warm water seas as the land subsequently separated. We foresaw that in the later era of the emergence of land life, large oceans of water would separate these drifting continental land masses. 5. The continental drift. The continental land drift continued. The Earth's core had become as dense and rigid as steel, being subjected to a pressure of almost 25,000 tons to the square inch, and owing to the enormous gravity pressure, it was and still is very hot in the deep interior. The temperature increases from the surface downward until at the center it is slightly above the surface temperature of the Sun. The outer 1,000 miles of the Earth's mass consists principally of different kinds of rock. Underneath are the denser and heavier metallic elements. Throughout the early and pre-atmospheric ages, the world was so nearly fluid in its molten and highly heated state that the heavier metals sank deep into the interior. Those found near the surface today represent the exudate of ancient volcanoes, later and extensive lava flows, and the more recent meteoric deposits. The outer crust was about 40 miles thick. This outer shell was supported by and rested directly upon a molten sea of basalt of varying thickness, a mobile layer of molten lava held under high pressure but always tending to flow hither and yon in equalization of shifting planetary pressures, thereby tending to stabilize the Earth's crust. Even today, the continents continue to float upon this non-crystallized, cushiony sea of molten basalt. Were it not for this protective condition, the more severe earthquakes would literally shake the world to pieces. Earthquakes are caused by sliding and shifting of the solid outer crust and not by volcanoes. The lava layers of the Earth's crust, when cooled, form granite. The average density of Urantia is a little more than 5½ times that of water. The density of granite is less than 3 times that of water. The Earth's core is 12 times as dense as water. The sea bottoms are more dense than the land masses, and this is what keeps the continents above water. When the sea bottoms are extruded above the sea level, they are found to consist largely of basalt, a form of lava considerably heavier than the granite of the land masses. Again, if the continents were not lighter than the ocean beds, gravity would draw the edges of the oceans up onto the land, but such phenomena are not observable. The weight of the oceans is also a factor in the increase of pressure on the sea beds. The lower but comparatively heavier ocean beds, plus the weight of the overlying water, approximate the weight of the higher but much lighter continents. But all continents tend to creep into the oceans. The continental pressure at ocean bottom levels is about 20,000 pounds to the square inch. That is, this would be the pressure of a continental mass standing 15,000 feet above the ocean floor. The ocean floor water pressure is only about 5,000 pounds to the square inch. These differential pressures tend to cause the continents to slide toward the ocean beds. Depression of the ocean bottom during the pre-life ages had upthrust a solitary continental landmass to such a height that its lateral pressure tended to cause the eastern, western, and southern fringes to slide downhill over the underlying semi-viscous lava beds into the waters of the surrounding Pacific Ocean. This so fully compensated the continental pressure that a wide break did not occur on the eastern shore of this ancient Asiatic continent, but ever since has that eastern coastline hovered over the precipice of its adjoining oceanic depths, threatening to slide into a watery grave. 6. The Transition Period. 450 million years ago, the transition from vegetable to animal life occurred. This metamorphosis took place in the shallow waters of the sheltered tropic bays and lagoons of the extensive shorelines of the separating continents. And this development, all of which was inherent in the original life patterns, came about gradually. There were many transitional stages between the early primitive vegetable forms of life and the later well-defined animal organisms. Even today, the transition slime molds persist, and they can hardly be classified either as plants or as animals. Although the evolution of vegetable life can be traced into animal life, and though there have been found graduated series of plants and animals which progressively lead up from the most simple to the most complex and advanced organisms, you will not be able to find such connecting links between the great divisions of the animal kingdom, nor between the highest of the pre-human animal types and the dawn men of the human races. These so-called missing links will forever remain missing, for the simple reason that they never existed. From era to era, radically new species of animal life arise. They do not evolve as the result of the gradual accumulation of small variations. They appear as full-fledged and new orders of life, and they appear suddenly. The sudden appearance of new species and diversified orders of living organisms is wholly biologic, strictly natural. There is nothing supernatural connected with these genetic mutations. At the proper degree of saltiness in the oceans, animal life evolved, and it was comparatively simple to allow the briny waters to circulate through the animal bodies of marine life. But when the oceans were contracted and the percentage of salt was greatly increased, these same animals evolved the ability to reduce the saltiness of their body fluids, just as those organisms which learnt to live in fresh water acquired the ability to maintain the proper degree of sodium chloride in their body fluids by ingenious techniques of salt conservation. Study of the rock-embraced fossils of marine life reveals the early adjustment struggles of these primitive organisms. Plants and animals never cease to make these adjustment experiments. Ever the environment is changing, and always are living organisms striving to accommodate themselves to these never-ending fluctuations. The physiologic equipment and the anatomic structure of all new orders of life are in response to the action of physical law, but the subsequent endowment of mind is a bestowal of the adjutant mind spirits in accordance with innate brain capacity. Mind, while not a physical evolution, is wholly dependent on the brain capacity afforded by purely physical and evolutionary developments. Through almost endless cycles of gains and losses, adjustments and readjustments, all living organisms swing back and forth from age to age. Those that attain cosmic unity persist, while those that fall short of this goal cease to exist. 7. The Geologic History Book. The vast group of rock systems which constituted the outer crust of the world during the Life Dawn or Proterozoic era does not now appear at many points on the Earth's surface, and when it does emerge from below all the accumulations of subsequent ages, there will be found only the fossil remains of vegetable and early primitive animal life. Some of these older water-deposited rocks are commingled with subsequent layers, and sometimes they yield fossil remains of some of the earlier forms of vegetable life, while on the topmost layers occasionally may be found some of the more primitive forms of the early marine animal organisms. In many places, these oldest stratified rock layers, bearing the fossils of the early marine life, both animal and vegetable, may be found directly on top of the older undifferentiated stone. Fossils of this era yield algae, coral-like plants, primitive protozoa, and sponge-like transition organisms. But the absence of such fossils in the early rock layers does not necessarily prove that living things were not elsewhere in existence at the time of their deposition. Life was sparse throughout these early times, and only slowly made its way over the face of the earth. The rocks of this olden age are now at the Earth's surface, or very near the surface, over about 1/8 of the present land area. The average thickness of this transition stone, the oldest stratified rock layers, is about 1½ miles. At some points, these ancient rock systems are as much as 4 miles thick, but many of the layers which have been ascribed to this era belong to later periods. In North America, this ancient and primitive fossil-bearing stone layer comes to the surface over the eastern, central, and northern regions of Canada. There is also an intermittent east-west ridge of this rock which extends from Pennsylvania and the ancient Adirondack Mountains on west through Michigan, Wisconsin, and Minnesota. Other ridges run from Newfoundland to Alabama and from Alaska to Mexico. The rocks of this era are exposed here and there all over the world, but none are so easy of interpretation as those about Lake Superior and in the Grand Canyon of the Colorado River, where these primitive fossil-bearing rocks, existing in several layers, testify to the upheavals and surface fluctuations of those faraway times. This stone layer, the oldest fossil-bearing stratum in the crust of the earth, has been crumpled, folded, and grotesquely twisted as a result of the upheavals of earthquakes and the early volcanoes. The lava flows of this age brought much iron, copper, and lead up near the planetary's surface. There are few places on the Earth where such activities are more graphically shown than in the St. Croix Valley of Wisconsin. In this region there occurred 127 successive lava flows on land with succeeding water submergence and consequent rock deposition. Although much of the upper rock sedimentation and intermittent lava flow is absent today, and though the bottom of this system is buried deep in the earth, nevertheless about 65 or 70 of these stratified records of past ages are now exposed to view. In these early ages, when much land was near sea level, there occurred many successive submergences and emergences. The Earth's crust was just entering upon its later period of comparative stabilization. The undulations, rises, and dips of the earlier continental drift contributed to the frequency of the periodic submergence of the great land masses. During these times of primitive marine life, extensive areas of the continental shores sank beneath the seas from a few feet to half a mile. Much of the older sandstone and conglomerates represents the sedimentary accumulations of these ancient shores. The sedimentary rocks belonging to this early stratification rest directly upon those layers which date back far beyond the origin of life, back to the early appearance of the world-wide ocean. Some of the upper layers of these transition rock deposits contain small amounts of shale or slate of dark colors, indicating the presence of organic carbon and testifying to the existence of the ancestors of those forms of plant life which overran the earth during the succeeding Carboniferous or Coal Age. Much of the copper in these rock layers results from water deposition. Some is found in the cracks of the older rocks, and is the concentrate of the sluggish swamp water of some ancient sheltered shoreline. The iron mines of North America and Europe are located in deposits and extrusions lying partly in the older unstratified rocks and partly in these later stratified rocks of the transition periods of life formation. This era witnesses the spread of life throughout the waters of the world. Marine life has become well established on Urantia. The bottoms of the shallow and extensive inland seas are being gradually overrun by a profuse and luxuriant growth of vegetation, while the shoreline waters are swarming with the simple forms of animal life. All of this story is graphically told within the fossil pages of the vast stone book of world record. And the pages of this gigantic biogeologic record unfailingly tell the truth if you but acquire skill in their interpretation. Many of these ancient seabeds are now elevated high upon land, and their deposits of age upon age tell the story of the life struggles of those early days. It is literally true, as your poet has said, the dust we tread upon was once alive.
Presented by a member of the Urantia Life Carrier Corps, now resident on the planet.
Paper 59. The Marine Life Era on Urantia. We reckon the history of Urantia as beginning about 1 billion years ago and extending through 5 major eras. 1. The pre-life era extends over the initial 450 million years, from about the time the planet attained its present size to the time of life establishment. Your students have designated this period as the Archaeozoic. 2. The Life Dawn era extends over the next 150 million years. This epoch intervenes between the preceding pre-life or cataclysmic age and the following period of more highly developed marine life. This era is known to your researchers as the Proterozoic. 3. The Marine Life era covers the next 250 million years and is best known to you as the Paleozoic. 4. The Early Land Life era extends over the next 100 million years and is known as the Mesozoic. 5. The Mammalian era occupies the last 50 million years. This recent times era is known as the Cenozoic. The marine life era thus covers about 1/4 of your planetary history. It may be subdivided into 6 long periods, each characterized by certain well-defined developments in both the geologic realms and the biologic domains. As this era begins, the sea bottoms, the extensive continental shelves, and the numerous shallow near-shore basins are covered with prolific vegetation. The more simple and primitive forms of animal life have already developed from preceding vegetable organisms, and the early animal organisms have gradually made their way along the extensive coastlines of the various land masses until the many inland seas are teeming with primitive marine life. Since so few of these early organisms had shells, not many have been preserved as fossils. Nevertheless, the stage is set for the opening chapters of that great stone book of the life record preservation which was so methodically laid down during the succeeding ages. The continent of North America is wonderfully rich in the fossil-bearing deposits of the entire marine life era. The very first and oldest layers are separated from the later strata of the preceding period by extensive erosion deposits, which clearly segregate these 2 stages of planetary development. 1. Early marine life in the shallow seas, the Trilobite Age. By the dawn of this period of relative quiet on the Earth's surface, life is confined to the various inland seas and the oceanic shoreline. As yet, no form of land organism has evolved. Primitive marine animals are well established and are prepared for the next evolutionary development. Amoeba are typical survivors of this initial stage of animal life, having made their appearance toward the close of the preceding transition period. 400 million years ago, marine life, both vegetable and animal, is fairly well distributed over the whole world. The world climate grows slightly warmer and becomes more equable. There is a general inundation of the seashores of the various continents, particularly of North and South America. New oceans appear, and the older bodies of water are greatly enlarged. Vegetation now for the first time crawls out upon the land, and soon makes considerable progress in adaptation to a non-marine habitat. Suddenly, and without gradation ancestry, the first multicellular animals make their appearance. The trilobites have evolved, and for ages they dominate the seas. From the standpoint of marine life, this is the trilobite age. In the later portion of this time segment, much of North America and Europe emerged from the sea. The crust of the earth was temporarily stabilized. Mountains, or rather high elevations of land, rose along the Atlantic and Pacific coasts, over the West Indies and in southern Europe. The entire Caribbean region was highly elevated. 390 million years ago, the land was still elevated. Over parts of eastern and western America and western Europe may be found the stone strata laid down during these times, and these are the oldest rocks which contain trilobite fossils. There were many long, finger-like gulfs projecting into the land masses in which were deposited these fossil-bearing rocks. Within a few million years, the Pacific Ocean began to invade the American continents. The sinking of the land was principally due to crustal adjustment, although the lateral land spread or continental creep was also a factor. 380 million years ago, Asia was subsiding, and all other continents were experiencing a short-lived emergence. But as this epoch progressed, the newly appearing Atlantic Ocean made extensive inroads on all adjacent coastlines. The northern Atlantic or Arctic seas were then connected with the southern Gulf waters. When this southern sea entered the Appalachian Trough, its waves broke upon the east against mountains as high as the Alps, but in general the continents were uninteresting lowlands, utterly devoid of scenic beauty. The sedimentary deposits of these ages are of four sorts. 1. Conglomerates, matter deposited near the shorelines. 2. Sandstones, deposits made in shallow water, but where the waves were sufficient to prevent mud settling. 3. Shales, deposits made in the deeper and more quiet water. 4. Limestone, including the deposits of trilobite shells in deep water. The trilobite fossils of these times present certain basic uniformities coupled with certain well-marked variations. The early animals developing from the three original life implantations were characteristic. Those appearing in the Western Hemisphere were slightly different from those of the Eurasian group and from the Australasian or Australian Antarctic type. 370 million years ago, the great and almost total submergence of North and South America occurred, followed by the sinking of Africa and Australia. Only certain parts of North America remained above these shallow Cambrian seas. 5 million years later, the seas were retreating before the rising land, and all of these phenomena of land sinking and land rising were undramatic, taking place slowly over millions of years. The trilobite fossil-bearing strata of this epoch outcrop here and there throughout all the continents except in Central Asia. In many regions these rocks are horizontal, but in the mountains they are tilted and distorted because of pressure and folding. And such pressure has, in many places, changed the original character of these deposits. Sandstone has been turned into quartz, shale has been changed to slate, while limestone has been converted into marble. 360 million years ago, the land was still rising. North and South America were well up. Western Europe and the British Isles were emerging, except parts of Wales, which were deeply submerged. There were no great ice sheets during these ages. The supposed glacial deposits appearing in connection with these strata in Europe, Africa, China, and Australia are due to isolated mountain glaciers or to the displacement of glacial debris of later origin. The world climate was oceanic, not continental. The southern seas were warmer then than now, and they extended northward over North America up to the polar regions. The Gulf Stream coursed over the central portion of North America, being deflected eastward to bathe and warm the shores of Greenland, making that now ice-mantled continent a veritable tropic paradise. The marine life was much alike the world over, and consisted of the seaweeds, one-celled organisms, simple sponges, trilobites, and other crustaceans, shrimps, crabs, and lobsters. 3,000 varieties of brachiopods appeared at the close of this period, only 200 of which have survived. These animals represent a variety of early life which has come down to the present time practically unchanged. But the trilobites were the dominant living creatures. They were sexed animals and existed in many forms. Being poor swimmers, they sluggishly floated in the water or crawled along the sea bottoms, curling up in self-protection when attacked by their later appearing enemies. They grew in length from 2 inches to 1 foot and developed into 4 distinct groups: carnivorous, herbivorous, omnivorous, and mud-eaters. The ability of the latter group largely to subsist on inorganic matter, being the last multicelled animal that could, explains their great increase and long survival. This was the biogeologic picture of Urantia at the end of that long period of the world's history, embracing 50 million years, designated by your geologists as the Cambrian. 2. The first continental flood stage, the invertebrate animal age. The periodic phenomena of land elevation and land sinking characteristic of these times were all gradual and non-spectacular, being accompanied by little or no volcanic action. Throughout all of these successive land elevations and depressions, the Asiatic mother continent did not fully share the history of the other land bodies. It experienced many inundations, dipping first in one direction and then another, more particularly in its earlier history, but it does not present the uniform rock deposits which may be discovered on the other continents. In recent ages, Asia has been the most stable of all the land masses. 350 million years ago saw the beginning of the great flood period of all the continents except Central Asia. The land masses were repeatedly covered with water. Only the coastal highlands remained above these shallow but widespread oscillatory inland seas. 3 major inundations characterized this period, but before it ended, the continents again arose, the total land emergence being 15% greater than now exists. The Caribbean region was highly elevated. This period is not well marked off in Europe because the land fluctuations were less, while the volcanic action was more persistent. 340 million years ago, there occurred another extensive land sinking, except in Asia and Australia. The waters of the world's oceans were generally commingled. This was a great limestone age, much of its stone being laid down by lime-secreting algae. A few million years later, large portions of the American continents and Europe began to emerge from the water. In the Western Hemisphere, only an arm of the Pacific Ocean remained over Mexico and the present Rocky Mountain regions, but near the close of this epoch, the Atlantic and Pacific coasts again began to sink. 330 million years ago marks the beginning of a time sector of comparative quiet all over the world, with much land again above water. The only exception to this reign of terrestrial quiet was the eruption of the great North American volcano of eastern Kentucky, one of the greatest single volcanic activities the world has ever known. The ashes of this volcano covered 500 square miles to a depth of from 15 to 20 feet. 320 million years ago, the third major flood of this period occurred. The waters of this inundation covered all the land submerged by the preceding deluge, while extending farther in many directions all over the Americas and Europe. Eastern North America and Western Europe were from 10,000 to 15,000 feet under water. 310 million years ago, the land masses of the world were again well up, excepting the southern parts of North America. Mexico emerged, thus creating the Gulf Sea, which has ever since maintained its identity. The life of this period continues to evolve. The world is once again quiet and relatively peaceful. The climate remains mild and equable. The land plants are migrating farther and farther from the seashores. The life patterns are well developed, although few plant fossils of these times are to be found. This was the great age of individual animal organismal evolution. though many of the basic changes, such as the transition from plant to animal, had previously occurred. The marine fauna developed to the point where every type of life below the vertebrate scale was represented in the fossils of those rocks which were laid down during these times. But all of these animals were marine organisms. No land animals had yet appeared, except a few types of worms which burrowed along the seashores, nor had the land plants yet overspread the continents. There was still too much carbon dioxide in the air to permit of the existence of air breathers. Primarily, all animals except certain of the more primitive ones are directly or indirectly dependent on plant life for their existence. The trilobites were still prominent. These little animals existed in tens of thousands of patterns and were the predecessors of modern crustaceans. Some of the trilobites had from 25 to 4,000 tiny islets. Others had aborted eyes. As this period closed, the trilobites shared domination of the seas with several other forms of invertebrate life, but they utterly perished during the beginning of the next period. Lime-secreting algae were widespread. There existed thousands of species of the early ancestors of the corals. Sea worms were abundant, and there were many varieties of jellyfish which have since become extinct. Corals and the later types of sponges evolved. The cephalopods were well developed, and they have survived as the modern pearly nautilus, octopus, cuttlefish, and squid. There were many varieties of shell animals, but their shells were not then so much needed for defensive purposes as in subsequent ages. The gastropods were present in the waters of the ancient seas, and they included single-shelled drills, periwinkles, and snails. The bivalve gastropods have come on down through the intervening millions of years, much as they then existed, and embrace the mussels, clams, oysters, and scallops. The valve-shelled organisms also evolved, and these brachiopods lived in those ancient waters much as they exist today. They even had hinged, notched, and other sorts of protective arrangements of their valves. So ends the evolutionary story of the second great period of marine life, which is known to your geologists Paper 60. Urantia during the early land life era. The era of exclusive marine life has ended. Land elevation, cooling crust and cooling oceans, sea restriction and consequent deepening, together with a great increase of land in northern latitudes, all conspired greatly to change the world's climate in all regions far removed from the equatorial zone. The closing epochs of the preceding era were indeed the age of frogs, but these ancestors of the land vertebrates were no longer dominant, having survived in greatly reduced numbers. Very few types outlived the rigorous trials of the preceding period of biologic tribulation. Even the spore-bearing plants were nearly extinct. 1. The early reptilian age. The erosion deposits of this period were mostly conglomerates, shale, and sandstone. The gypsum and red layers throughout these sedimentations over both America and Europe indicate that the climate of these continents was arid. These arid districts were subjected to great erosion from the violent and periodic cloudbursts on the surrounding highlands. Few fossils are to be found in these layers, but numerous sandstone footprints of the land reptiles may be observed. In many regions, the 1,000 feet of red sandstone deposit of this period contains no fossils. The life of land animals was continuous only in certain parts of Africa. These deposits vary in thickness from 3,000 to 10,000 feet, even being 18,000 on the Pacific coast. Lava was later forced in between many of these layers. The Palisades of the Hudson River were formed by the extrusion of basalt lava between these Triassic strata. Volcanic action was extensive in different parts of the world. Over Europe, especially Germany and Russia, may be found deposits of this period. In England, the new red sandstone belongs to this epoch. Limestone was laid down in the southern Alps as the result of a sea invasion, and may now be seen as the peculiar dolomite limestone walls, peaks, and pillars of those regions. This layer is to be found all over Africa and Australia. The Carrara marble comes from such modified limestone. Nothing of this period will be found in the southern regions of South America, as that part of the continent remained down, and hence presents only a water or marine deposit continuous with the preceding and succeeding epochs. 150 million years ago, the early land life periods of the world's history began. Life, in general, did not fare well, but did better than at the strenuous and hostile close of the marine life era. As this era opens, the eastern and central parts of North America, the northern half of South America, most of Europe, and all of Asia are well above water. North America for the first time is geographically isolated, but not for long, as the Bering Strait land bridge soon again emerges, connecting the continent with Asia. Great troughs developed in North America, paralleling the Atlantic and Pacific coasts. The great eastern Connecticut Fault appeared, one side eventually sinking 2 miles. Many of these North American troughs were later filled with erosion deposits, as also were many of the basins of the fresh and saltwater lakes of the mountain regions. Later on, these filled land depressions were greatly elevated by lava flows which occurred underground. The petrified forests of many regions belong to this epoch. The Pacific coast, usually above water during the continental submergences, went down, excepting the southern part of California and a large island which then existed in what is now the Pacific Ocean. This ancient California Sea was rich in marine life and extended eastward to connect with the old sea basin of the Midwestern region. 140 million years ago, suddenly, and with only the hint of the 2 pre-reptilian ancestors that developed in Africa during the preceding epoch, the reptiles appeared in full-fledged form. They developed rapidly, soon yielding crocodiles, scaled reptiles, and eventually both sea serpents and flying reptiles. Their transition ancestors speedily disappeared. These rapidly evolving reptilian dinosaurs soon became the monarchs of this age. They were egg layers, and are distinguished from all animals by their small brains, having brains weighing less than 1 pound to control bodies later weighing as much as 40 tons. But earlier reptiles were smaller, carnivorous, and walked kangaroo-like on their hind legs. They had hollow avian bones, and subsequently developed only 3 toes on their hind feet, and many of their fossil footprints have been mistaken for those of giant birds. Later on, the herbivorous dinosaurs evolved. They walked on all fours, and one branch of this group developed a protective armor. Several million years later, the first mammals appeared. They were non-placental and proved a speedy failure. None survived. This was an experimental effort to improve mammalian types, but it did not succeed on Urantia. The marine life of this period was meager, but improved rapidly with the new invasion of the sea, which again produced extensive coastlines of shallow waters. Since there was more shallow water around Europe and Asia, the richest fossil beds are to be found about these continents. Today, if you would study the life of this age, examine the Himalayan, Siberian, and Mediterranean regions, as well as India and the islands of the southern Pacific basin. A prominent feature of the marine life was the presence of hosts of the beautiful ammonites, whose fossil remains are found all over the world. 130 million years ago, the seas had changed very little. Siberia and North America were connected by the Bering Strait land bridge. A rich and unique marine life appeared on the Californian Pacific coast, where over 1,000 species of ammonites developed from the higher types of cephalopods. The life changes of this period were indeed revolutionary, notwithstanding that they were transitional and gradual. This period extended over 25 million years and is known as the Triassic. 2. The later Reptilian Age. 120 million years ago, a new phase of the Reptilian Age began. The great event of this period was the evolution and decline of the dinosaurs. Land animal life reached its greatest development in point of size, and had virtually perished from the face of the earth by the end of this age. The dinosaurs evolved in all sizes, from a species less than 2 feet long up to the huge non-carnivorous dinosaurs, 75 feet long, that have never since been equaled in bulk by any living creature. The largest of the dinosaurs originated in western North America. These monstrous reptiles are buried throughout the Rocky Mountain regions, along the whole of the Atlantic coast of North America, over Western Europe, South Africa, and India, but not in Australia. These massive creatures Paper 61. The Mammalian Era on Urantia. The era of mammals extends from the times of the origin of placental mammals to the end of the Ice Age, covering a little less than 50 million years. During this Cenozoic age, the world's landscape presented an attractive appearance: rolling hills, broad valleys, wide rivers, and great forests. Twice during this sector of time, the Panama Isthmus went up and down. 3 times Bering Strait land bridge did the same. The animal types were both many and varied. The trees swarmed with birds, and the whole world was an animal paradise, notwithstanding the incessant struggle of the evolving animal species for supremacy. The accumulated deposits of the 5 periods of this 50-million-year era contain the fossil records of the successive mammalian dynasties and lead right up through the times of the actual appearance of man himself. 1. The new continental land stage, the age of early mammals. 50 million years ago, the land areas of the world were very generally above water, or only slightly submerged. The formations and deposits of this period are both land and marine, but chiefly land. For a considerable time the land gradually rose, but was simultaneously washed down to the lower levels and toward the seas. Early in this period, and in North America, the placental type of mammals suddenly appeared, and they constituted the most important evolutionary development up to this time. Previous orders of non-placental mammals had existed, but this new type sprang directly and suddenly from the pre-existent reptilian ancestor whose descendants had persisted on down through the times of dinosaur decline. The father of the placental mammals was a small, highly active, carnivorous, springing type of dinosaur. Basic mammalian instincts began to be manifested in these primitive mammalian types. Mammals possess an immense survival advantage over all other forms of animal life in that they can 1. Bring forth relatively mature and well-developed offspring. 2. Nourish, nurture, and protect their offspring with affectionate regard. 3. Employ their superior brain power in self-perpetuation. 4. Utilize increased agility in escaping from enemies. 5. Apply superior intelligence to environmental adjustment and adaptation. 45 million years ago, the continental backbones were elevated in association with a very general sinking of the coastlines. Mammalian life was evolving rapidly. A small reptilian, egg-laying type of mammal flourished, and the ancestors of the later kangaroos roamed Australia. Soon there were small horses, fleet-footed rhinoceroses, tapirs with proboscises, primitive pigs, squirrels, lemurs, opossums, and several tribes of monkey-like animals. They were all small, primitive, and best suited to living among the forests of the mountain regions. A large ostrich-like land bird developed to a height of 10 feet and laid an egg 9 by 13 inches. These were the ancestors of the later gigantic passenger birds that were so highly intelligent and that one time transported human beings through the air. The mammals of the early Cenozoic lived on land, under the water, in the air, and among the treetops. They had from 1 to 11 pairs of mammary glands, and all were covered with considerable hair. In common with the later appearing orders, they developed 2 successive sets of teeth and possessed large brains in comparison to body size. But among them all, no modern forms existed. 40 million years ago, the land areas of the northern hemisphere began to elevate, and this was followed by new extensive land deposits and other terrestrial activities, including lava flows, warping, lake formation, and erosion. During the latter part of this epoch, most of Europe was submerged. Following a slight land rise, the continent was covered by lakes and bays. The Arctic Ocean, through the Ural Depression, ran south to connect with the Mediterranean Sea as it was then expanded northward, the highlands of the Alps, Carpathians, Apennines, and Pyrenees being up above the water as islands of the sea. The Isthmus of Panama was up. The Atlantic and Pacific Oceans were separated. North America was connected with Asia by the Bering Strait land bridge, and with Europe by way of Greenland and Iceland. The Earth's circuit of land in northern latitudes was broken only by the Ural Straits, which connected the Arctic seas with the enlarged Mediterranean. Considerable foraminiferal limestone was deposited in European waters. Today, this same stone is elevated to a height of 10,000 feet in the Alps, 16,000 feet in the Himalayas, and 20,000 feet in Tibet. The chalk deposits of this period are found along the coasts of Africa and Australia, on the west coast of South America, and about the West Indies. Throughout this so-called Eocene period, the evolution of mammalian and other related forms of life continued with little or no interruption. North America was then connected by land with every continent except Australia, and the world was gradually overrun by primitive mammalian fauna of various types. 2. The recent flood stage, the age of advanced mammals. This period was characterized by the further and rapid evolution of placental mammals, the more progressive forms of mammalian life developing during these times. Although the early placental mammals sprang from carnivorous ancestors, very soon herbivorous branches developed, and, ere long, omnivorous mammalian families also sprang up. The angiosperms were the principal food of the rapidly increasing mammals. The modern land flora, including the majority of present-day plants and trees, having appeared during earlier periods. 35 million years ago marks the beginning of the age of placental mammalian world domination. The southern land bridge was extensive, reconnecting the then enormous Antarctic continent with South America, South Africa, and Australia. In spite of the massing of land in high latitudes, the world climate remained relatively mild because of the enormous increase in the size of the tropic seas, nor was the land elevated sufficiently to produce glaciers. Extensive lava flows occurred in Greenland and Iceland, some coal being deposited between these layers. Marked changes were taking place in the fauna of the planet. The sea life was undergoing great modification. Most of the present-day orders of marine life were in existence, and foraminifers continued to play an important role. The insect life was much like that of the previous era. The florissant fossil beds of Colorado belong to the later years of these far distant times. Most of the living insect families go back to this period, but many then in existence are now extinct, though their fossils remain. On land, this was preeminently the age of mammalian renovation and expansion. Of the earlier and more primitive mammals, over 100 species were extinct before this period ended. Even the mammals of large size and small brain soon perished. Brains and agility had replaced armor and size in the progress of animal survival. And with the dinosaur family on the decline, the mammals slowly assumed domination of the Earth, speedily and completely destroying the remainder of their reptilian ancestors. Along with the disappearance of the dinosaurs, other and great changes occurred in the various branches of the saurian family. The surviving members of the early reptilian families are turtles, snakes, and crocodiles, together with the venerable frog, the only remaining group representative of man's earlier ancestors. Various groups of mammals had their origin in a unique animal now extinct. This carnivorous creature was something of a cross between a cat and a seal. It could live on land or in water, and was highly intelligent and very active. In Europe, the ancestor of the canine family evolved, soon giving rise to many species of small dogs. About the same time, the gnawing rodents, including beavers, squirrels, gophers, mice, and rabbits, appeared, and soon became a notable form of life, very little change having since occurred in this family. The later deposits of this period contain the fossil remains of dogs, cats, coons, and weasels in ancestral form. 30 million years ago, the modern types of mammals began to make their appearance. Formerly, the mammals had lived for the greater part in the hills, being of the mountainous types. Suddenly, there began the evolution of the plains or hoofed type, the grazing species, as differentiated from the clawed flesh-eaters. These grazers sprang from an undifferentiated ancestor having 5 toes and 44 teeth, which perished before the end of the age. Toe evolution did not progress beyond the 3-toed stage throughout this period. The horse, an outstanding example of evolution, lived during these times in both North America and Europe, though his development was not fully completed until the later Ice Age. While the rhinoceros family appeared at the close of this period, it underwent its greatest expansion subsequently. A small hog-like creature also developed, which became the ancestor of the many species of swine, peccaries, and hippopotamuses. Camels and llamas had their origin in North America about the middle of this period and overran the western plains. Later, the llamas migrated to South America, the camels to Europe, and soon both were extinct in North America, though a few camels survived up to the Ice Age. About this time, a notable thing occurred in western North America. The early ancestors of the ancient lemurs first made their appearance. While this family cannot be regarded as true lemurs, their coming marked the establishment of the line from which the true lemurs subsequently sprang. Like the land serpents of a previous age, which betook themselves to the seas, now a whole tribe of placental mammals deserted the land and took up their residence in the oceans. And they have ever since remained in the sea, yielding the modern whales, dolphins, porpoises, seals, and sea lions. The bird life of the planet continued to develop, but with few important evolutionary changes. The majority of modern birds were existent, including gulls, herons, flamingos, buzzards, falcons, eagles, owls, quails, and ostriches. By the close of this Oligocene period, covering 10 million years, the plant life, together with the marine life and the land animals, had very largely evolved and was present on Earth much as today. Considerable specialization has subsequently appeared, but the ancestral forms of most living things were then alive. 3. The modern mountain stage, age of the elephant and the horse. Land elevation and sea segregation were slowly changing the world's weather, gradually cooling it, but the climate was still mild. Sequoias and magnolias grew in Greenland, but the subtropical plants were beginning to migrate southward. By the end of this period, these warm climate plants and trees had largely disappeared from the northern latitudes, their places being taken by more hardy plants and the deciduous trees. There was a great increase in the varieties of grasses, and the teeth of many mammalian species gradually altered to conform to the present-day grazing type. 25 million years ago, there was a slight land submergence following the long epoch of land elevation. The Rocky Mountain region remained highly elevated, so that the deposition of erosion material continued throughout the lowlands to the east. The Sierras were well re-elevated. In fact, they have been rising ever since. The Great 4-Mile Vertical Fault in the California region dates from this time. 20 million years ago was indeed the golden age of mammals. Bering Strait land bridge was up, and many groups of animals migrated to North America from Asia, including the 4-tusked mastodons, short-legged rhinoceroses, and many varieties of the cat family. The first deer appeared, and North America was soon overrun by ruminants, deer, oxen, camels, bison, and several species of rhinoceroses, but the giant pigs, more than 6 feet tall, became extinct. The huge elephants of this and subsequent periods possessed large brains as well as large bodies, and they soon overran the entire world except Australia. For once, the world was dominated by a huge animal with a brain sufficiently large to enable it to carry on. Confronted by the highly intelligent life of these ages, no animal the size of an elephant could have survived unless it had possessed a brain of large size and superior quality. In intelligence and adaptation, the elephant is approached only by the horse and is surpassed only by man himself. Even so, of the 50 species of elephants in existence at the opening of this period, only 2 have survived. 15 million years ago, the mountain regions of Eurasia were rising, and there was some volcanic activity throughout these regions, but nothing comparable to the lava flows of the Western Hemisphere. These unsettled conditions prevailed all over the world. The Strait of Gibraltar closed, and Spain was connected with Africa by the old land bridge, but the Mediterranean flowed into the Atlantic through a narrow channel which extended across France, the mountain peaks and highlands appearing as islands above this ancient sea. Later on, these European seas began to withdraw. Still later, the Mediterranean was connected with the Indian Ocean, while at the close of this period, the Suez region was elevated so that the Mediterranean became, for a time, an inland salt sea. The Iceland land bridge submerged, and the Arctic waters commingled with those of the Atlantic Ocean. The Atlantic coast of North America rapidly cooled, but the Pacific coast remained warmer than at present. The great ocean currents were in function and affected climate much as they do today. Mammalian life continued to evolve. Enormous herds of horses joined the camels on the western plains of North America. This was truly the age of horses, as well as of elephants. The horse's brain is next in animal quality to that of the elephant, but in one respect it is decidedly inferior, for the horse never fully overcame the deep-seated propensity to flee when frightened. The horse lacks the emotional control of the elephant, while the elephant is greatly handicapped by size and lack of agility. During this period, an animal evolved which was somewhat like both the elephant and the horse, but it was soon destroyed by the rapidly increasing cat family. As Urantia is entering the so-called horseless age, you should pause and ponder what this animal meant to your ancestors. Men first used horses for food, then for travel, and later in agriculture and war. The horse has long served mankind and has played an important part in the development of human civilization. The biologic developments of this period contributed much toward the setting of the stage for the subsequent appearance of man. In Central Asia, the true types of both the primitive monkey and the gorilla evolved, having a common ancestor, now extinct. But neither of these species is concerned in the line of living beings which were, later on, to become the ancestors of the human race. The dog family was represented by several groups, notably wolves and foxes, the cat tribe by panthers and large saber-toothed tigers, the latter first evolving in North America. The modern cat and dog families increased in numbers all over the world. Weasels, martens, otters, and raccoons thrived and developed throughout the northern latitudes. Birds continued to evolve, though few marked changes occurred. Reptiles were similar to modern types: snakes, crocodiles, and turtles. Thus drew to a close a very eventful and interesting period of the world's history. This age of the elephant and the horse is known as the Miocene. 4. The recent continental elevation stage, the last great mammalian migration. This is the period of pre-glacial land elevation in North America, Europe, and Asia. The land was greatly altered in topography. Mountain ranges were born, streams changed their courses, and isolated volcanoes broke out all over the world. 10 million years ago began an age of widespread local land deposits on the lowlands of the continents, but most of these sedimentations were later removed. Much of Europe at this time was still underwater, including parts of England, Belgium, and France, and the Mediterranean Sea covered much of northern Africa. In North America, extensive depositions were made at the mountain bases, in lakes, and in the great land basins. These deposits average only about 200 feet, are more or less colored, and fossils are rare. Two great freshwater lakes existed in western North America. The Sierras were elevating. Shasta, Hood, and Rainier were beginning their mountain careers. But it was not until the subsequent Ice Age that North America began its creep toward the Atlantic Depression. For a short time, all the land of the world was again joined, excepting Australia, and the last great worldwide animal migration took place. North America was connected with both South America and Asia, and there was a free exchange of animal life. Asiatic sloths, armadillos, antelopes, and bears entered North America, while North American camels went to China. Rhinoceroses migrated over the whole world except Australia and South America, but they were extinct in the Western Hemisphere by the close of this period. In general, the life of the preceding period continued to evolve and spread. The cat family dominated the animal life, and marine life was almost at a standstill. Many of the horses were still three-toed, but the modern types were arriving. Llamas and giraffe-like camels mingled with the horses on the grazing plains. The giraffe appeared in Africa, having just as long a neck then as now. In South America, sloths, armadillos, anteaters, and the South American type of primitive monkeys evolved. Before the continents were finally isolated, those massive animals, the mastodons, migrated everywhere except to Australia. 5 million years ago, the horse evolved as it now is, and from North America migrated to all the world. But the horse had become extinct on the continent of its origin long before the red man arrived. The climate was gradually getting cooler. The land plants were slowly moving southward. At first, it was the increasing cold in the north that stopped animal migrations over the northern isthmuses. Subsequently, these North American land bridges went down. Soon afterwards, the land connection between Africa and South America finally submerged, and the Western Hemisphere was isolated much as it is today. From this time forward, distinct types of life began to develop in the Eastern and Western Hemispheres. And thus does this period of almost 10 million years' duration draw to a close, and not yet has the ancestor of man appeared. This is the time usually designated as the Pliocene. 5. The Early Ice Age. By the close of the preceding period, the lands of the northeastern part of North America and of northern Europe were highly elevated on an extensive scale. In North America, vast areas rising up to 30,000 feet and more. Mild climates had formerly prevailed over these northern regions, and the Arctic waters were all open to evaporation, and they continued to be ice-free until almost the close of the glacial period. Simultaneously with these land elevations, the ocean currents shifted, and the seasonal winds changed their direction. These conditions eventually produced an almost constant precipitation of moisture from the movement of the heavily saturated atmosphere over the northern highlands. Snow began to fall on these elevated and therefore cool regions, and it continued to fall until it had attained a depth of 20,000 feet. The areas of the greatest depth of snow, together with altitude, determined the central points of subsequent glacial pressure flows. And the Ice Age persisted just as long as this excessive precipitation continued to cover these northern highlands with this enormous mantle of snow, which soon metamorphosed into solid but creeping ice. The great ice sheets of this period were all located on elevated highlands, not in mountainous regions where they are found today. 1/2 of the glacial ice was in North America, 1/4 in Eurasia, and 1/4 elsewhere, chiefly in Antarctica. Africa was little affected by the ice, but Australia was almost covered with the Antarctic ice blanket. The northern regions of this world have experienced 6 separate and distinct ice invasions, although there were scores of advances and recessions associated with the activity of each individual ice sheet. The ice in North America collected in 2 and later 3 centers. Greenland was covered, and Iceland was completely buried beneath the ice floe. In Europe, the ice at various times covered the British Isles, excepting the coast of southern England, and it overspread Western Europe down to France. 2 million years ago, the first North American glacier started its southern advance. The Ice Age was now in the making, and this glacier consumed nearly 1 million years in its advance from and retreat back toward the northern pressure centers. The central ice sheet extended south as far as Kansas. The eastern and western ice centers were not then so extensive. 1,500,000 years ago, the first great glacier was retreating northward. In the meantime, enormous quantities of snow had been falling on Greenland and on the northeastern part of North America, and ere long this eastern ice mass began to flow southward. This was the second invasion of the ice. These first 2 ice invasions were not extensive in Eurasia. During these early epochs of the Ice Age, North America was overrun with mastodons, woolly mammoths, horses, camels, deer, musk oxen, bison, ground sloths, giant beavers, saber-toothed tigers, sloths as large as elephants, and many groups of the cat and dog families. But from this time forward, they were rapidly reduced in numbers by the increasing cold of the glacial period. Toward the close of the Ice Age, the majority of these animal species were extinct in North America. Away from the ice, the land and water life of the world was little changed. Between the ice invasions, the climate was about as mild as at present, perhaps a little warmer. The glaciers were, after all, local phenomena, though they spread out to cover enormous areas. The coastwise climate varied greatly between the times of glacial inaction and those times when enormous icebergs were sliding off the coast of Maine into the Atlantic, slipping out through Puget Sound into the Pacific, and thundering down Norwegian fjords into the North Sea. 6. Primitive man in the Ice Age. The great event of this glacial period was the evolution of primitive man. Slightly to the west of India, on land now underwater and among the offspring of Asiatic migrants of the older North American lemur types, the dawn mammals suddenly appeared. These small animals walked mostly on their hind legs, and they possessed large brains in proportion to their size and in comparison with the brains of other animals. In the 70th generation of this order of life, a new and higher group of animals suddenly differentiated. These new mid-mammals, almost twice the size and height of their ancestors and possessing proportionately increased brain power, had only well established themselves when the primates, the third vital mutation, suddenly appeared. At this same time, a retrograde development within the mid-mammal stock gave origin to the simian ancestry, and from that day to this, the human branch has gone forward by progressive evolution, while the simian tribes have remained stationary or have actually retrogressed. 1 million years ago, Urantia was registered as an inhabited world. A mutation within the stock of the progressing primates suddenly produced 2 primitive human beings, the actual ancestors of mankind. This event occurred at about the time of the beginning of the third glacial advance. Thus it may be seen that your early ancestors were born and bred in a stimulating, invigorating, and difficult environment. And the sole survivors of these Urantia aborigines, the Eskimos, even now prefer to dwell in frigid northern climes. Human beings were not present in the Western Hemisphere until near the close of the Ice Age. But during the interglacial epochs, they passed westward around the Mediterranean and soon overran the continent of Europe. In the caves of Western Europe may be found human bones mingled with the remains of both tropic and Arctic animals, testifying that man lived in these regions throughout the later epochs of the advancing and retreating glaciers. 7. The continuing Ice Age. Throughout the glacial period, other activities were in progress, but the action of the ice overshadows all other phenomena in the northern latitudes. No other terrestrial activity leaves such characteristic evidence on the topography. The distinctive boulders and surface cleavages, such as potholes, lakes, displaced stone, and rock flour, are to be found in connection with no other phenomenon in nature. The ice is also responsible for those gentle swells or surface undulations known as drumlins. And a glacier, as it advances, displaces rivers and changes the whole face of the earth. Glaciers alone leave behind them those telltale drifts, the ground, lateral, and terminal moraines. These drifts, particularly the ground moraines, extend from the eastern seaboard north and westward in North America and are found in Europe and Siberia. 750,000 years ago, the fourth ice sheet, a union of the North American central and eastern ice fields, was well on its way south. At its height, it reached to southern Illinois, displacing the Mississippi River 50 miles to the west, and in the east it extended as far south as the Ohio River and central Pennsylvania. In Asia, the Siberian ice sheet made its southernmost invasion, while in Europe the advancing ice stopped just short of the mountain barrier of the Alps. 500,000 years ago, during the fifth advance of the ice, a new development accelerated the course of human evolution. Suddenly, and in one generation, the 6 colored races mutated from the aboriginal human stock. This is a doubly important date, since it also marks the arrival of the planetary prince. In North America, the advancing fifth glacier consisted of a combined invasion by all 3 ice centers. The eastern lobe, however, extended only a short distance below the St. Lawrence Valley, and the western ice sheet made little southern advance. But the central lobe reached south to cover most of the state of Iowa. In Europe, this invasion of the ice was not so extensive as the preceding one. 250,000 years ago, the 6th and last glaciation began, and despite the fact that the northern highlands had begun to sink slightly, this was the period of greatest snow deposition on the northern ice fields. In this invasion, the 3 great ice sheets coalesced into one vast ice mass, and all of the western mountains participated in this glacial activity. This was the largest of all ice invasions in North America. The ice moved south over 1,500 miles from its pressure centers, and North America experienced its lowest temperatures. 200,000 years ago, during the advance of the last glacier, there occurred an episode which had much to do with the march of events on Urantia, the Lucifer Rebellion. 150,000 years ago, the 6th and last glacier reached its farthest points of southern extension, the western ice sheet crossing just over the Canadian border, the central coming down into Kansas, Missouri, and Illinois, the eastern sheet advancing south and covering the greater portion of Pennsylvania and Ohio. This is the glacier that sent forth the many tongues or ice lobes which carved out the present-day lakes, great and small. During its retreat, the North American system of Great Lakes was produced, and Urantia geologists have very accurately deduced the various stages of this development and have correctly surmised that these bodies of water did, at different times, empty first into the Mississippi Valley, then eastward into the Hudson Valley, and finally, by a northern route, into the St. Lawrence. It is 37,000 years since the connected Great Lakes system began to empty out over the present Niagara route. 100,000 years ago, during the retreat of the last glacier, the vast polar ice sheets began to form, and the center of ice accumulation moved considerably northward. And as long as the polar regions continue to be covered with ice, it is hardly possible for another glacial age to occur, regardless of future land elevations or modification of ocean currents. This last glacier was 100,000 years advancing, and it required a like span of time to complete its northern retreat. The temperate regions have been free from the ice for a little over 50,000 years. The rigorous glacial period destroyed many species and radically changed numerous others. Many were sorely sifted by the to and fro migration which was made necessary by the advancing and retreating ice. Those animals which followed the glaciers back and forth over the land were the bear, bison, reindeer, musk ox, mammoth, and mastodon. The mammoth sought the open prairies, but the mastodon preferred the sheltered fringes of the forest regions. The mammoth, until a late date, ranged from Mexico to Canada. The Siberian variety became wool-covered. The mastodon persisted in North America until exterminated by the red man, much as the white man later killed off the bison. In North America, during the last glaciation, the horse, tapir, llama, and saber-toothed tiger became extinct. In their places, sloths, armadillos, and water hogs came up from South America. The enforced migration of life before the advancing ice led to an extraordinary commingling of plants and of animals, and with the retreat of the final ice invasion, many Arctic species of both plants and animals were left stranded high upon certain mountain peaks, whither they had journeyed to escape destruction by the glacier. And so, today, these dislocated plants and animals may be found high up on the Alps of Europe and even on the Appalachian Mountains of North America. The Ice Age is the last completed geologic period, the so-called Pleistocene, over 2 million years in length. 35,000 years ago marks the termination of the Great Ice Age, excepting in the polar regions of the planet. This date is also significant in that it approximates the arrival of a material son and daughter and the beginning of the Adamic dispensation, roughly corresponding to the beginning of the Holocene or post-glacial period. This narrative, extending from the rise of mammalian life to the retreat of the ice and on down to historic times, covers a span of almost 50 million years. This is the last, the current geologic period, and is known to your researchers as the Cenozoic or recent times era.
Sponsored by a resident life carrier.